So, arrays, sequence of values of the same type. All numbers, all words. A list is a sequence of values that can be not restricted to the same type. But we've been pretending that they're arrays, right? So we've been only putting data of the same type in there. Except for Monday, when we read in a line from the file, and it had a word in the beginning, it had somebody's name, and then it had some data. Well, that was really in a list. And it would have caused us a little bit of problem if we were trying to, treat that as a row of numbers. We could have handled it. So arrays are fixed in length, meaning you can't append, you can't insert, you can't delete items from the middle. Now, when I say you can't, of course you can. You can do anything with computers. But what it requires is if you have 10 items and you want to append something, you have to reallocate the array to 11 items long, and then copy the items in one by one, and then put your new item at the 10. Sounds easy, right? But what if your array is 100 items? What if your array is 1,000 items? You don't want to have to reallocate every single time you feel like adding a name to it. That's a whole bunch of copying around. And yeah, nowadays computers are incredibly fast, but still, you're writing a game which is supposed to run as fast as possible, or you're controlling the engine of a car or something like that where you're needing to respond to events real time. You don't want to be wasting time by having, arrays be reallocated just because you want to delete something from the middle. How would you delete something from the middle? Right? It's 10 items long. You want to remove the 5th item. Well, then you allocate an array that's 9 items long. And then you copy everything into it except for the item that you deleted. Now, are there ways you can get around that? Yeah. You can put a special symbol there for that, missing item. And, you can do stuff like that. But if you have a tool like a list that makes it easy, that's how you're going to do it. So arrays are fixed in length. Lists are not. They grow and shrink as required. So what you typically do is you start a list with a length of 0. An array of length 0 doesn't even make any sense, right? But a list of 0 is great because you can start adding items to it. So they grow and shrink as required, meaning that you can append, you can remove, / delete. Now the reason I'm using those two different words is they pretty much sound like they mean the same thing, right? I'm going to remove you from the class, I'm going to delete you from the class. That sounds silly, right? But you're going to remove a piece of data, you're going to delete a piece of data. They sound like the same thing. And in effect they are. It's just that Python has two different commands because one of them removes it by the item number, right? You want to remove something from the first element, you do a remove command. But if you want you do a del command that removes them by item number, by index number. But if you wanted to search the array to delete it, then you use the remove command. And we'll go back to that in a minute. So if I want to search my inventory for all my oranges, I can say remove oranges. It'll go, remove. I better put that as a little note already while I'm mentioning it. Remove by value, delete by item number, by index number, by subscript. You can insert, including inserting at the beginning. Inserting at the beginning is really easy. Show you how to do it. Alrighty, what else can we do? We could count. These are things that you could do with both arrays and lists. Count the number of times something appears in it. You could replace items in it, right? You change your name, right, legally. So I'm going to replace your record with another one. you could get the index number of it. You could search the array and find the index number. So with this ability and deleting my index and subscript, right, if you could find it, get the index number, and then delete my index, you wouldn't really need the remove by value, right? But then you're doing several commands. You could check to see if an item is in the array. Is value in array. I'm going to put in quotes because that's the exact word that you use. All right, that's a lot of stuff to remember. I think that's enough to go through today. I guess I'll add the comment, which I've already said. Python uses lists, not arrays, but we have been simulating. But we have been treating lists as arrays so far, meaning that we allocated them to a certain length, right? And then we never deleted anything. We never appended anything. Oh, and one more thing. We could sort the data, right? Now, why did I break this stuff into two categories of things you can do only to a list and things that you can do to arrays and lists? Well, because in Python you can do absolutely all of these things because all we have is lists. But if you're using another language that has arrays, these are the things that are list specific. Append, remove, delete, insert. All right. I think we're good to go to actually use some of this code. First, I'm going to type a demonstration. I'm going to use capital L for the name of my list. So that's how I create an empty list. So I can start appending to it. And then L.append, I'm going to add a number to it. L.append, I'm going to add another number to it. L.append, I'm going to add another number to it, right? And then I'm going to insert a value into the beginning of it. And I'm going to do this again in idle so that we're all going to be doing it together. I'm going to insert into the first space. So whatever I insert is going to be the new subscript 0. You know, I want a 100 there. Now I'm going to sort my data, right? Because now it's out of order. 100, 10, 20, 30 is what it looks like at this point. But I could resort it. So L.sort, right? That would sort it. I'm not going to even put a comment there. That's pretty easy. All right, then I'm going to remove one of the values. I'm going to delete L at the position 1, right? So after we sort it, it says 10, 20, 30, 100, right? But which one of these is item 1? The 10, the 20, the 30, or the 40? 10. That's item 0. Yep. So it's going to be the 20, right? So after we're done with this, it's going to say 20, 30, 100. Now we want to remove the 30, but we don't know its position, at least not without using a find. So L.remove that 30. And then we're going to have, a 20 and a 100 in our list. And I'm not taking the time to type commas between them. Alrighty. So we're going to play with those commands right there. But when you remove a value, if that value isn't in the list, it'll generate an error. It'll pop up your red text. It'll generate a runtime error. So that's not cool. So what you ought to do is check to see if that value is in the list before you delete it. Because if it's not in the list, you can't issue a delete command. A remove command on it. Of course you can do it that way, as long as the index number is valid. So what we're going to do is if 30 in list, remove it. But if it's not in there, either we tell the user that it's not or we just, don't do anything. All right, what did I have up here that's L? Well, count isn't all that cool because we don't have, more than anything. But, you know, C is equal to L dot count. How many 100s are in my list? Well, we see how many 100s are in my list. I've only got one. Replace. L dot replace that 100 with a 200. Now, I believe it does a replace all. I could be wrong about that. You know, change them all. We'll find out. Alrighty, so once we've done that, we have a 20 and a 200, right? Because we replaced the 100 with a 200. So we've done sorting, we've done counting, we've done a replace. We didn't do find the index value. Again, our data is so small that it doesn't really matter, but you know. I for index value is equal to L dot find 200. And which value is 200? Is it 0, 1, or 2? What's its index number? Yeah, it's index 1. So I is going to equal 1 at that point. Pop up here, see if we've done them all. We've sorted it. We've checked the value. We did a find. We did a replace. We did a count. We did an append. We did a remove by value. We did a delete. We did an insert. So we've done everything that we have in our goal up here, in our list of things you can do. Let's do it again. Let's do it in for reals with idle. Except I may do it with words rather than numbers. So file, insert, save as. Just don't save it in your Python directory. I know I say that every time, but I had somebody whose Python wouldn't even load because they accidentally saved a file into Python. So, put it in my usual place. I'm going to call this May2 lists because that's what we're talking about, right? Alrighty, so our name, our date. What is this? It's a demonstration of Python lists. Alright, what we have been doing in the past is creating an array like this, right? We would do A is equal to, and we would fill it with values. You know, 1, 2, 3. We're not going to do that this time. We're not going to initialize our array, because we're talking about lists. We aren't going to initialize with a series of values. Instead, we will make an empty list. So names is equal to that. Square braces, not parentheses. So empty list. Now it's cool if we ask, you know, for names, that we start appending the items to the names with input commands, but then every single time we run it, we're going to have to, you know, type in those names again, and that gets kind of tedious. So we're just going to fake it. Names.append Abe or Alice, some name with an A, and you don't have to use the same names, and you don't have to make them in alphabetical order, although I'm going to do this. Names.append, you know, Carol. Yeah, I skipped B on purpose. And then names.append Fred. Like that. And maybe a fourth one and a fifth one. Just pick a couple more names. You know, Nick. And then names.append Zeke. Whatever names you're feeling today. Let's print our list out just to ogle it. Now in the exam I'll probably say something like use a for loop to print the list. We've already done that several times, right? So for now I'm just going to be using a single print command, which doesn't print them, you know, one per line. It just dumps them out in kind of an ugly format for us to debug. But all we have to do is print the list like that. Let's run it and make sure it's working so far. All right, and it printed our names. And see appending, put them in order. Let's insert a name into the beginning of the list. Remember that insert command. We're going to insert at position 0 so that it winds up there. If we insert it at position 1, it would not replace Carol. It would wind up being before Carol. If we insert it into position 3, it would wind up being before Nick. But we want it at the beginning of the list. So names.append, names.insert at position 0. Let's do Bob. And then print it out again. Just so that we can see that happen. So, print, quote, after insert, end quote, comma, names. Just so we know what happened there, right? Because when it scrolls by and it's just a huge list of stuff, we don't really know what happened at that point. All right, so I ran it, and yeah, Bob got put into the beginning of my list, or whatever you inserted. What if I decide that looks nasty because I wanted them in alphabetical order? I'm going to do a names.sort. So, is anybody getting red text so far? I should wander around. I'm going to put a comment on this insert 0. 0 will insert into beginning of list. Alrighty, let's go for it. We're going to sort it. Names.sort. Parentheses now. Everything has been parentheses except for this. This was the only one where we used square braces. I know it's hard in the back row to see what a parentheses is and what a square brace is. And I'm not being sarcastic. Okay. Now let's print, parentheses, quote, after sort, end quote, our names. Cool beans. Let's print it and run it, and I'll walk around. Not print it and run it. Let's run it, see what it does. Okay, I'm going to temporarily cover the code so that we can see the results. Here was our initial list after our 5 appends, Abe, Carol, Fred, etc. Then we did an insert. Bob wound up being at the beginning of the list. Then we did a sort. And so Abe wound up being at the beginning of the list. Now sorting is relatively expensive in terms of time compared to appending or inserting. You know, that's pretty easy for the computer to do. Put something at the beginning, put something at the end, delete it. But if you're doing a sort, you know, it's going to have to shuffle a lot of things rather than just, you know, insert it into the list or something like that. So you're not going to really want to sort every single time you add an item to the list if your list is going to get very long, right? If we have 10,000 items in our inventory, we're not going to want to sort every time something gets removed or appended. There are other ways to handle that. Maybe you're going to wait until they quit the program and then you're going to sort the data before you write it back out. That kind of thing. Okay. Are we all good? Anybody need me to come look? Alrighty. We have done a lot of what we were doing. Let's remove somebody from the list. And again, it'd be cool if we asked which item we were going to remove, right? S is equal, but this is going to get kind of tiresome, so we're going to probably wind out commenting this out. But S is equal to input, remove which name, question mark, end, question mark. That way, we won't just remove the same number every time, the same person every time. But like I said, the more often we run it, the more tired we get of typing names. We need to check to make sure it's in the list before we try to remove it. To me, it's kind of annoying that we have to do that, but we'll cope with it. So if S in IN names colon, then remove it. Names dot remove S, whatever S contains, Fred, Zeke, whatever they type in. But it better match the case, right? So when you type in Fred or Nick or whatever, make sure it's got an initial cap. Let's go ahead and put an else statement saying that we didn't find it. Else colon, I'm going to push this up. I did hit record again. Good. Alrighty. Else print S comma quote not found. All right, just to let them know, hey, you typed it wrong. Then realistically, we'd probably ask them to type in another name, right? Until they get it right. Alrighty, now let's print it out one more time. Print, parentheses, quote, after remove, end quote, comma, and then print our names array. List, names list. We're going to want to test that out. Run it and delete one of the names from your list. Or run it and try deleting something that doesn't exist. All right, remove which name? Bob needs to take a hike. Okay, so Bob. After the removing, it says Abe, Carol, Fred, right? It was removed by value. That's what remove means in this language. Remove does a remove by value. Maybe I'll even add a comment to that effect. Let's remove somebody else just out of sheer cussedness. So, names.remove, and then pick another one of your names, right? But again, we ought to do this if syntax. I'm going to delete Abe from my list. Just delete one of the items that are in your list if you didn't type the same names I did. So, again, we have to do that if trick. If, quote, Abe, end quote, in names, colon, names.remove, Abe, quote, Abe, end quote, parentheses. Now, we didn't ask the user for that. We're just doing it for fun, right? Well, we didn't ask the user to append those names. I just want you to see this syntax without a variable, right? You know what? I'm going to take that after. No, I'm going to leave it alone. But you might just copy that print after remove statement and paste it, right? That's faster than typing. So I'm going to copy that print statement, come down here and paste it. All right. We have done most of what we set out to do. We didn't use .find. We didn't use, .count, stuff like that. We'll probably make another list before we do that. I'm getting tired of our names list. But let's run it, make sure it's working. Alrighty, remove which name? Bob. And then after our first remove, yep, Bob is gone, but then I also said remove Abe. So Abe also disappeared. Last thing I'm going to do, not remove, but delete. Remember that remove removes by value, delete deletes by index number. So I'm going to remove whatever item 1 is, just for grins. excuse me, delete. Okay, so we're going to do a DEL, and then we're going to do another print. So DEL names subscript 1 because I want the second item gone. And then print, after DEL. I'm going to put a comment here. Delete by index. And then print, quote, after DEL, end quote, comma, names. Same business. If I was doing a lot of removes, I would get tired of doing this if syntax. And what I might do is just write a function that would do it. It would check for the value first, and then it would remove it. Maybe. All right, that's looking pretty good in my opinion. I don't think we need to do anything else with our names list. Yes, we do. We got to print it out with a for loop. It's our favorite thing to do. And remember, we've talked about two ways. You can use a for index, or you can use a for value. Let's use a for index first. For I in range. Now remember, you can start off at 0, but you can also leave that 0 off. So I'm going to leave that 0 off. For I in range, maybe I won't. For I in range, starting at 0, and then as long as we don't exceed the length of the list. len names. Colon. Print. And let's print that number out. Let's print our index out, followed by names subscript I. We have that index number. Why not? Now we're going to do a value-based loop. So we don't use a range, right? We just do for value or for v in names. For v in names, colon, print v. That one sure is shorter. So this one is awesome. I would use this one all the time unless I need the index number. When do you need the index number? When you're treating parallel arrays, right? Because those items are related by their index number. All right, let's run this puppy. Remove which name? Abe. There it goes. And then it printed out my names. The first time, we see the index numbers, 0, 1, 2, and 3. The second time we see Bob, Fred, Nick, and Zeke. Now there's some other things that we've kind of given short shrift to, like checking to see if something is all uppercase or lowercase, checking to see if something is a number or not. I think I'm just going to remove those questions from the exam because I don't want to pile a lot of stuff on the last week, right? And then make the exam over a lot of stuff from the last week. At least it's fresh in mind, but we haven't hit it several times. I'm going to show you the syntax though, right? I would if I could remember it. So let's do another input. S is equal to input, type anything, number, word, etc. Now let's find out if what they typed is all numbers. I'm not going to convert it to an int or a float. Why? Because if they type in a word, that would generate, an exception. It would stop running, an error. So if s dot is alpha, hope that's the correct syntax. We're going to find out soon. Colon, let's print a message. Print, your word is all letters. I better tack these onto the notes. But I think I will remove them from the exam. If S dot is digit, if it's all digits. Now there's a problem with is digit is it doesn't check, it doesn't allow minus signs, right? And if you typed in minus 100 to a human, that's a number. And to the computer, it's a number, but then when it checks all digit, that hyphen is not a number. Kind of a drag. So print, you typed all numbers. Now let's do one more thing. Let's check to see if it's all alphanumeric. Alphanumeric means it's letters or numbers, right? But if they type in periods and percents and stuff like that, it's not going to all be alphanumeric. You know, if we lecture about this stuff again on Monday, we'll consider it. Because you can always reference your notes. If S dot is alnum, A-L-N-U-M, alnum, print, you typed all alphanumeric. Fancy word, just means all letters and numbers. Now let's check to see if it's all uppercase. If S dot is upper, print, it was all uppercase. And then guess what? Type if S dot is lower, right? If S dot is lower, colon, print, it was all lowercase. That's about enough. If you want to check to see if it's all punctuation, what do? If not S dot is alnum. Well, I went and checked to see if it was all punctuation. It's hard to do if all punctuation. I can't really think of a way to do that. I guess you would do if not is alpha and not is digit. No, that still wouldn't work. Forget it. We're not going to do all punctuation. I can't think of a way to do it. I think we better run this to make sure it works. Run module. All right. I'm going to delete Bob. And then it's going to ask me for type anything, a number, a word, whatever. I'm going to type in something in all uppers. A-P-P-L-E, apple. Whatever you want to type is fine. And it says my word is all letters. I typed in alphanumeric. That's true. There weren't any numbers in it this time, but it does consist of all letters and or numbers. And it was all uppercase. Cool deal. I'm going to run it one more time and type in something else. I don't think that we need to type in 5 different types of data, 6 different types of data to test it all. Yes, if you were going to ship this to a customer, you would test every root. It's very important to test every if statement to make that if statement be true and that if statement be positive. Just like if you had a flow chart, you would want to test while you were testing your program every single path through your program. But we're going to cheat. Time is of the essence. So I'm going to type in something else. All right. I'm going to type in something that's not in that list just to make sure that that command worked. All right. But then type in anything. It's going to be a mix of lowercase and uppercase. And it's going to have a number in it. Numbers. 1, 2, 3. Again, I typed all alphanumeric, but it didn't say anything about is upper, right? And it didn't say it was all alpha, which the other one did because it was all letters. So we kind of narrowed it down. If we're careful enough, we could get it so that, if we typed in something with punctuation, it probably wouldn't say anything because none of these rules would work. It wouldn't be all alpha, it wouldn't be all numbers, it wouldn't be all letters and numbers, it wouldn't be all uppercase, and it wouldn't be all lowercase because it had punctuation in it. I feel like testing that. So run it, type one more thing, well, remove a name, and then type in something that has punctuation in it, periods. Oh, it said it was all lowercase. Hey, check that out. All lowercase ignores punctuation, which means that all upper ignores punctuation as well. That makes me curious about a number with a decimal point. Sorry to get curious and run off, but let's do that again. 123.4. It didn't print anything, right? Because it wasn't all digits. See what I said about it ignoring negatives? You know, the hyphen sign, not counting that as a digit. It also doesn't count a period. When in reality, that's a perfectly fine digit. You could write your own function that would check real carefully to see if it was a number. It could check to see if the first symbol and only the first symbol was a minus sign. And if that was true, then it could keep checking. And then it could check to see if there was one and only one period. I think that's worth writing because it's a logic problem, right? So DEF, we're going to call this is underscore real underscore num. Or how about is float? That's a better term. So what are our conditions? I'm going to put a few comments here. If there's only one minus and it's at the beginning, that's one thing we have to check. If that's not true, we got to return a false. And we need to check to make sure it's only got one period, one dot. If there's only one period. I think I'm going to change that minus sign to a dash, right? Because that minus sign kind of makes the comment hard to read. And, well, here's where it gets hard. You know, I'm going to skip this. What we would have to do is investigate it character by character. And you can do that with a string. You can kind of treat it like it was an array. You could start at the beginning and you could go down. I don't want to overly belabor this. I'm going to delete that. In earlier semesters, I've had us write a password program, right? Because you know, when you create a new password, it has to follow different rules, and every site has, you know, different rules for what's acceptable. But, you know, commonly, it's got to have a number, it's got to have an uppercase and a lowercase letter, it's got to have, you know, a special symbol, a punctuation, and then it's got to be of a certain length, right? And so to do that, we would have to break it down character by character. Let's do that part at least. Let's break it down character by character. For char in our string s, we're just going to print out that char. Print char. So that whatever they typed, we'll see, you know, those characters, one per line. Just proving that a string is like a list or an array. So remove which name. After our sort. Why did it stop there? Is it ask? You mean to type in something else? Huh. I think I made a mistake. I don't know what I did wrong. But it finally got down to the point where it said type anything. I'm going to type in something. It was all alphanumeric. It was all lowercase. And then it printed it out letter by letter, character by character. All right, all well and good. Let's make some numbers. Let's make another list of numbers. Nums is equal to, and this time we are going to initialize our list. Right? Why not? Just put some numbers in. I just typed a quote, don't do that. Whatever your favorite numbers are. They don't have to be sorted. Just type in, I don't know, 10 numbers or something. But that's ugly, so why don't we sort it? What are we going to type to sort it?
Nums.sort.
Yep, nums.sort, parentheses in parentheses. Now, whenever I'm walking around helping people, people often leave off the parentheses. And I understand that. But if it's a function call, if it's trying to do something to the data, it's always going to have parentheses, right? If it's data itself, it's not going to have parentheses. You know, so char didn't have parentheses, s didn't have parentheses. But everything else, a print command, an is lower, anything that's checking or modifying the data is going to have parentheses. So, nums.sort. Let's delete the first items from the list, the first two items from the list. Oh boy, I've skipped an entire topic. I've skipped slicing. Big topic, and I've skipped it because we were doing arrays, and arrays, all right. So slicing. Slicing is when you, to do our slicing, we're going to do it with a string. We're going to change gears. S is equal to, quote, A, B, C, D, E, F, G, H, I, J, K. Something like that. Now we're going to print out the first 5 characters. So print S subscript 0, starting at the first one, and then going up to and not including the 5th character. See, that's a slightly different syntax, right? Our index looks funky here. This is called slicing. Slicing your array. Why? Because we're taking only a section of it. So this means starting at that index, going up to and not including. So 0 is 12, 1 is 14, 2 is 54, 3 is 561, 4 is 34. It's not going to get the 1. Now, does that make sense? Yeah. All right, just think of it like this. You're starting at position 1 and you're going to grab 5. So it's going to be 12, 14, 54, 561. That's 4. Oh, but I should be using the letters. It's going to be A, B, C, D, E, and stop there. Right. Elements 0, 1, 2, 3, and 4. So by the time that's done, it's going to be equal to A, B, C, D, E. You can leave off that 0 if you're starting from the beginning of the list. This is just a comment, kind of a comment. I don't consider it the most important thing in the world. But if you do just comma 5, it starts at the beginning of the list. And that's kind of a big whoop, right? Because all we had to do is type a 0. Same thing. Let's make sure that that's the case, though. And we're getting to the point where it's really annoying to have to type this stuff in over and over. And what do you know? I typed the wrong syntax. And the reason I typed the wrong syntax is because it's not a comma. I apologize for making a mistake there. It's not a comma. It's a quote. This says starting at 0 and going out to 5. It was my mistake to have a comma there. And then a comma on the next one. Take the comma out and replace it with a quote, a single quote, not a semicolon or anything. You don't have to space it out like I did. So if I do that again, it's going to be slicing, and it's going to get A, B, C, D, E out of it. What if I don't want to start at 0? Let's say I want to start at character 2. I want to start at C, and I want it to go out to E. So I want 3 characters. So what is index for C? 0, 1, 2. I'm going to start at character 2, and I want 3 characters because I said I wanted C, D, and E. So I'm going to slice 2, comma 5, starting at 2, and then 3 more. 2 plus 3 is 5. So print, parentheses, S, starting at 2 and going out, so 2 colon 5 in square brace. And so this is going to slice it, and it's going to say CDE. And all this stuff works with arrays and lists as well. I just did a string because it's real easy to conceptualize, right? Like that. Like that? Okay, cool deal. What if I want to get something to the end? There's an annoying way, and then there's a simple way. I'm going to call this one last 4. No, I'm not going to call it last 4. But I want to go from position 5 all the way out to the end. So that's position 0, 1, 2, 3, 4. So I'm going to wind up with F all the way out to K. Now how could I do that? Yeah, I know the number of characters in this string, right? So I could figure it out. It would start, at 5 and then be, at 6 long. So 5 plus 6 is 11. My second number would be an 11. But that's uncool, right? Because we don't know how long this string is going to be. So what we could do is get the length of the string. And it's getting a little bit more obscure in its syntax, a little bit harder to read, which is why there's a shortcut for it. So S, starting at 5, and then going out to the length of S, right? Going all the way out to the end. I'm going to skip putting the word slicing because now you know if it's got a colon in it, it's slicing. And so that's going to get starting at character 5. 0, 1, 2, 3, 4, 5. So it's going to get G-H-I-J-K. G-H-I-J-K. But that's ugly, ain't it? This len.s makes it harder to read. This was also clean. So all you do is you leave off the last number after the colon, right? We left off the number before the colon, and it was a 0. You leave off the number after the colon, and it does that. So, lastly, print S starting at character 5, colon, and nothing else. And you don't have to space it out like I do, right? I just do that to make it easier to read. And then an end parentheses. That's going to do the same thing. G-H-I-J-K. All right, I'm going to put some comments here. So I'm going to type 3 quotes so that I can type multiple lines of comments. Using a colon in your subscript creates a slice. So if it's X comma Y, excuse me, there I go again, X colon Y, start at position X and go up to, but not including, Y. If you leave off that first thing, that starts at position 0. You leave off the last thing after the colon, that starts at X and goes to the end. And we demonstrated all that. And what's the easy way to think of it? Example. I want to start, I better push that up. I want to start at position 4 for index and position are synonymous. I want to start at position 4 and go and get 3 characters. So X will be 4, right? Our first number will be 4. Y will be 4 plus 3, right? So our slice will be starting at 4, colon, and going out to 7. That makes sense. That's a lot easier in my mind than figuring out, that, up to but not including business. Let's do one more example. I'm going to make a new string. S is equal to I space love space Python, end quote. Why is it not going to the beginning of the line anymore when I type something? I wonder if something's gone wrong. I better run this. I haven't run this in a while. I may have it strewn with errors. Yeah, I do. Anybody spot what I did wrong there? I forgot my square brace, right? Because for every open square brace, you need a closed square brace. So if you typed exactly what I typed, go to this one that had LENS and add a square brace. And later on, I could go back and I could delete all these, spaces like that, just to make it look more programmerese. But for now, I don't mind the spaces. Okay. Say I want a slice that only has the word love in it. Now don't do this if I ask this on an exam. Don't say S is equal to love. Instead, I want to use a slice. So, print, parentheses, quote. Now where does love start? At what index position? And no quote, sorry. What's the index position of the L in love? I think it's 2. I could be wrong. 0, 1, 2. It's the third position, so it's 2. So, S2. And then how long is our string? How many letters are there in love? 4, right. So, 2 plus 4 is 6. So it's going to print out love. What if I wanted to print the word Python only? I want a slice that has the word Python. And again, don't just do print Python. I said slice. So, I'm not going to make you tell me what position that is. I'm going to count it myself. 0, 1, 2, 3, 4, 5, 6, 7. I want it to start at position 7. Print S7. Now the word Python is 6, so I could go out from 7 to 13, but I can also take advantage that it's going all the way to the end of the string. I'm going to do it both ways. That would get, 7 going out to 13. That would get us 6 characters because the difference between 7 and 13 is 6. Or just go to the end of the string. Print S, starting at 7, and then a colon, and then nothing after that to take advantage of the go to the end of the string business. Alrighty. I still haven't been running it often enough, which means that, all right, Abe, whatever, type in a word, letter, whatever. And then it printed out all of our stuff, which if we push this over here and we scroll up to see what we thought we were going to get, let's make sure they're one and the same. Yeah, come on. That they're one and the same. Where's my output with my shell? All right. So A, B, C, D, E, yup. A, B, C, D, E, yup. C, D, E, yup. Well, what do you know? I goofed. F, G, H, I, J, K. I must have just counted wrong. I did the same mistake that's been cropping up in the classes. I didn't do zero-based indexing. Starting at character 5 is not that, apparently. So, 0, 1, 2, 3, 4. Should have started at F. My mistake. I must have just counted wrong. There we go. I just modified my comments so that they were actually correct. I didn't want misinformation, false news in there. Okay. So, and then we got the word love and we got the word Python like requested. I think that's the end of slicing. I know that we're going to do slicing again. We didn't do another example of file I/O. So we're going to tack on one more thing and then be done with class real soon. So, input, okay, file name is equal to input, quote, save data to what file, question mark, end quote, end parentheses. Now don't get confused between the words file and file name. So our file name is what we are going to open. File is actually our file. So file is equal to open, parentheses, file name, comma, W. Remember, if it was R, it would mean for reading. So comment. W for write, R for read. Now let's make a loop that's going to print out our names list, except write is the correct term in this case, not print. So I think a for value loop would be the easiest to write. For v in names, colon, file.write, because that's how you save to a file, file.write that name. And by the way, there's going to be a mistake in here. It's going to run without an error, but it's not going to look good. We will fix that. Now let's print out our, that's enough really, right? No, did we have a series of numbers up here we were playing with too? Not a very good series. All I had, all we did is sort it. But we did. Let's do that again. So for v in nums, colon, not names, nums, do the same thing. File.write, parentheses v. Then, anytime you open a file, you have to close it as soon as you're done with it. And I've said this before. Why? Because the operating system may keep it locked, and if it's locked, you might not be able to copy it to a new array. I mean, to a new, you may not be able to move it. You've probably have all seen that error, right? Where you try to move a file, and it says file is opened by your application. So anyways, file.close. Got to always do that. All right, run it, type in all the stuff you got to type in, and then at the very end, save it to a document called list.txt. And then use idle to open up list.txt. So file, run module. All right, remove a name, type in a word or whatever. And then the last thing it asks for is save to what file? List.txt. Now, it didn't have to be uppercase. I just happen to have shift lock on there. And whoa, ho, ho, it blew up. I don't even want to fix that. Just delete that second for v in nums file.write. Now, that error I didn't intend. I know how to fix it, but I don't want to waste our time. I guess it wouldn't be a waste, but we're getting close to the end. Remove which name, type in a string, give a file name, list.txt. Now we should have added one final print statement, right? Data saved to file, so that we knew it did something. Well, that's good enough. That's good enough. We trust it. Okay, I'm going to do a file open because I want to find that list file. Now where it says Python files, change it to all files, right? If you're going to open a text file, you can't open a Python file. It's looking for only py files. Or change it to txt. That's actually the best. And there's my list.txt. I open it up and check it out. That's not too cool, right? What I would need to do is to add on a /n. /n means go to the next line. So let's do that. After we write the v, let's do a file.write quote \n. That's backslash, which is the one above the enter key, not below the question mark. Sure, getting annoying having to input that stuff, just like I predicted at the list.txt. Do a file open, change it to text, open your text file. It's going to look a lot better. And it is time to stop, and I'll make a Dropbox, and if you need help, I'll do my walkabout. All right, list dot, and there it did. It printed it one per line rather than all mushed together. What's the technical term for mushed? Concatenated, right. Everything on one line. All right, we have created a file and we wrote to it. We didn't do that often enough. We'll probably do that again on Monday. So remember what we're doing. On Monday, we'll do a review. On Monday, we'll play with these topics just a little bit more so that they'll be burned into your brain. And there's a reading assignment that I want you to do. I'll post the reading assignment. Check your notices real soon. It's going to link to 2 short web pages. One, maybe just one. Lists. We're going to link to the lists web page. So over the weekend, please read that web page. All right. Time to crank up the file. Dropbox. By the way, I recommend taking C++ over the summer. Just because you're going to be bored over the summer, right? Or take Java in the fall. Or better yet, both. And I know a lot of y'all don't need an extra programming course. But although Python is popular, there are a lot of other languages that are popular too. And if you can tell somebody, yeah, I know Python, Java, and C++, going to get a better job. All right, refresh your Dropbox. Down in, look for QRSTU. Look for you. You'll see it. And we have a short homework assignment that you can do real easily just looking at this file that you already created. Let me show you what it is. Homework. Our list of books. That's what this assignment is. Create a list called books, right? It's not going to be names or numbers. It's going to be called books. Add 3 books with appending. Then insert 3 more books. Just make up names, and I don't care if they're books, you know, movies, whatever. And then delete the second book. Remove by value one of the books with a books.remove. Print the books. Then print the books with a for loop. You know, you can use either for index, for I in range, or for value in books. I didn't even do slicing. That was lame of me. But that's our homework. Alrighty. I'm going to stop the recording, walk about. I'm sure that I have a couple of folks who need a little bit of help. Any questions? Are we all good? Reminder, you can take the exam on Wednesday or you can wait the following week.
You still going over it with us on Monday?
Yeah, we're going to do a review and we're going to cover a little bit more file writing and some of this list stuff again, just to burn it into our brains.